Hello everyone, welcome to today's lecture. In this lecture we are going to learn about the HDFS storage. So in our previous lecture we have seen that the architecture of HDFS, and in this we have also seen that all the real data are stored at the data node. So how this data is stored? So files in the HDFS are broken into the block size chunk called data blocks. So suppose I want to upload one file, so that data of that file is divided into the blocks, and these blocks are stored as independent units. The size of the HDFS data blocks is 128 MB by default. So suppose my file size is 228 MB, then this whole file is divided into different blocks, and each block has size 128 MB by default. So we can configure the block size as per our requirement by changing the dfs.block.size property in hdfs-site.xml. So suppose I want to change the default size and I want to make it 228 MB. So at that time there is one XML file, so hdfs-site.xml. So we need to change the property dfs.block.size in that file. So that is how we can change the default block size. Hadoop distributes these blocks on different slaves machine, and the master machine stores the metadata about blocks location. So here all that blocks is stored at the data nodes, and the information about each and every blocks, the location of each and every block, is stored as a metadata in the name node. All the blocks of the file are the same size except the last one, so if the file size is not a multiple of 128. So let's understand it with example. So suppose this is one file and the size of the file is 612 MB, and as we already know that the default size is 128 MB. So for that we are dividing this file into the different blocks A, B, C, D, E, and the size of the each block is 128, 128, 128 and 128, but the remaining size is only 100 MB. So in that case the last block size is not a 128 MB, but the size is the remaining MB, which is 100 MB. So that is how the block is created in the HDFS and stored at the data node. So from this example we can conclude that a file in the HDFS smaller than the single block does not occupy a full block size space of the underlying storage, and each file stored in the HDFS doesn't need to be an exact multiple of configured block size. So that is about the HDFS storage. Now the next is Hadoop MapReduce paradigm. Hadoop MapReduce is the processing units of Hadoop. In the MapReduce approach, the processing is done at the slave nodes and the final result is sent to the master node. So as we know that now data is stored, but for the processing the method used is a Hadoop MapReduce, and in this approach all the processing is done at slave nodes, means all the processing is also happen at the data nodes in which the data is stored, and all that after this all processing the resultant data is sent to the master node. A data containing code is used to process the entire data. The code data, this coded data is usually a very small in comparison to the data itself. You only need to send a few kilobytes worth of code to perform a heavy duty process on computers. So in this Hadoop MapReduce contains a small data which contains a processing codes. So we are just running that few sites of code, and this can handle the huge amounts of data in the Hadoop. So let's understand it with example. So suppose we have input data, and the data has bus, car, train, sheep, train, bus, sheep, car. So this is a unordered data from the database. So the input data set is the first splits into the chunks of data. In this example the input has 3 lines of text with 3 separate entities: bus, car, train, sheep, train, and bus, sheep, car. Yes, we have this 3 different rows and total 9 entries is there. So in the map phase, the data is assigned a key and value of 1. In this case, we have one bus, one car, one ship and one train. So in this, first we'll split the data into different rows. So in the first block, the data is bus, car, train. Second block, data is ship, train. In the third block, the data is bus, ship, car. Now we are in the map phase. We are providing a index value. So here the bus is repeated one time, so index is 1. Car is repeated one time, so 1. Train is repeated one time. Same as in the ship is repeated 1. Another ship is also repeated 1. Train is repeated 1. So same as in the bus, ship, car, we are assigning the index value 1. The key value pair are then shuffled and sorted together. So here now this data is shuffled and sorted. In the shuffle and sorted phase, in this we can find that the data who are similar are in the same group. So it is some kind of clustering. So here the bus is in the one group. All the car in the one group, all the ship in the one group, and all the train in the one group. And based on their keys, at the reduce phase, the aggregation takes place and the final output is obtained. So as you can see that at the reduce phase we are reducing the data. So here bus is repeated 2 times, car is repeated 2 times, ship is repeated 3 times, and train is repeated 2 times. So this is how we are changing only the index amount, and so from this bulky data, input data, we will get the reduced data. So that is why it is called MapReduce. First we map the data, and after based on the mapping we reduce the data. So that is how the MapReduce is worked in the Hadoop. Now the next is common Hadoop Shell command. Suppose we have installed the Hadoop on our operating system. So there are some commands, and based on that we can use the Hadoop. So for that, first command is a version. So for finding the version, we have to write Hadoop version. So it shows the current version of Hadoop, which here in the example Hadoop version is 3.1.2. Same as the second command is HDFS mkdir command. So it is used to make the directory over the Hadoop. So the command is Hadoop fs-mkdir and then path of the directory in which we want to create the directory. So here we have write this command, and at new data flare the directory is created. Third is a ls command is used for list out the file. Suppose we are at the C drive, and if I write the ls commands, and it shows all the items, all the folders, list of all the folders which is on the C drive. So this is how the listing of files or listing of folders is show by using ls command. Next is a put command. Suppose there is some data on our local PC and I want to move it to the Hadoop. So at that time Hadoop fs-put command is used, and the path of local source and then the destination source. So this is how the file is replaced. Next is copy from local. Suppose I want to copy some data, here in which put command take the data from local and move to the destination address, while in this copy command we are copying from local to the HDFS destination. So the command is Hadoop fs-copy from local, then the path of local file and the path of the destination. So this is how data is used. Now here you can, in this example you can see the one cat command. So cat command is used to display the data from the file. So that is all about the common Hadoop shell commands, and that's it about today's lecture. Thank you so much for listening.